right, so this is an example where we are filling a water tank in the shape of a cylinder with water. So let's start off by reading this question here. It says a water tank has the shape of an upright cylinder. The cylinder is filling at a rate of 1.5 meters cubed per minute. So that is the rate at which my volume is changing with respect to time, which is in minutes. If the tank has a radius of 200 centimeters, at what rate is the water level increasing when the water depth is 320 centimeters? Okay, so what we want to do first is draw ourselves a diagram here. So since we're working with the cylinder, I'm going to of course start off by drawing a cylinder. Okay. All right, so let's label some dimensions that we know here. They do tell you that the water tank has a radius of 200 centimeters, but watch out. One thing that I mentioned in class is watch that your units are the same. Notice that the volume, the rate at which the volume increases in meters cubed, whereas this is in centimeters, so you need to convert. I'm going to convert centimeters to meters for this question. So we all know that in 1 meter we have 100 centimeters. So my radius, the value of my radius is going to be 2 meters. Okay. Also, they tell you, of course, that your volume is increasing 1.5 meters cubed per minute. So that's the rate at which my volume is increasing with respect to time. So I'm going to write it out in Leibniz notation. dV dt is equal to 1.5 meters cubed per minute. And because it's increasing, it's going to be a positive value. So the question wants you to find at what rate is the water level increasing when the water depth is 320. Okay, so in other words, what is the value of dHdt? What is the rate at which the height is changing with respect to time? Okay, so once we take a little bit of a snapshot of what's happening here, we want to, of course, pick out some formulas. But one thing I should also mention here is that if I'm drawing my water, it's increasing just like this. All right, so my height is of course changing. Okay. All right, so let's get into the second part of this question, which is the formulas. So since we're working with the volume of a cylinder, I'm going to start out with the volume of a cylinder formula, which is of course on your formula sheet. But if you have it memorized from all those years of using it, that's great too. In step 3, you always want to substitute any fixed values. We do have a fixed value for this question. Notice that as the height is increasing, one dimension that does not change is, of course, the radius. So it stays 2 meters the whole way. So that's a fixed value, so you can sub that in. Volume is equal to pi 2 meters squared times the h value. So if I clean this up a little bit, it's going to be 4 pi h, okay? Moving into step 4 now, you want to implicitly derive, you want to take the derivative implicitly with respect to time. So I'm going to start off by writing the derivative of volume with respect to time is equal to, so if you take the derivative of the right-hand side, you treat this as a constant. So you're going to have 4 pi times the derivative of h with respect to volume, which is 1. However, if we're implicitly deriving this with respect to time, we're going to have dH dt that follows. Okay? All right, so dV dt is going to be equal to 4 pi dH dt. So I'm just cleaning this up a little bit. Remember what the question wants you to find. The question wants you to state the value of which the h value is changing with respect to time. So we're trying to find this expression or find that value. Okay, so remember, we do know what dV dt is. They tell you in the question it's increasing at a rate of 1.5 meters cubed per minute. Okay, so that's going to go in for dV dt. We have 4 pi dH dt. So as you can see here, we are almost there. The last thing we need to do is, of course, get rid of the 4 pi on this side so we can isolate dH dt. Okay, so that's going to cancel these out. So I'm going to be left with dH dt is equal to 1.5 over 4 pi, or you can write it out as dH dt is equal to 3 over 8 pi. Okay, so these are our two answers right here. Watch the units. This is the rate at which the height is changing with respect to time. So remember, we are working with meters. So meters per minute. Meters per minute. Okay, so that is the rate at which my height is changing with respect to time. Okay, so that's how you do that question. Also notice this is positive, so of course it's positive because it's increasing as your water level or as your water is being poured into this tank. Okay, so that's how you do this question.